Hey guys, it's Miss Nichols. I hope you guys all had a fun spring break. Hopefully you found something fun to do. Um, I know it's probably not like your other spring breaks in the past, but hopefully you made the best of it. Um, so we're going to start back from break by doing quadratic transformations. To transform something means to change it. So we're going to take a parabola, which is one of the U-shaped graphs we've been graphing, and I'm going to shift it up, down, left, and right. And we're going to see what happens to the equation when you do that. Okay, so first what we want to do is we want to graph something called, and if you look right here, it's called the parent function. So it is y equals x squared. So if you read this, it says, fill in the table below by substituting in the given values of x into the equation y equals x squared. Then use the table to graph the parent function on the coordinates provided below. So what I'm going to do, instead of plugging these in, I'm just going to use my table and my calculator. So go to your table, and we're going to type in, it was y equals x squared, so just x squared. And when you do, you get a parabola. If you look, the vertex is at 0, 0 at the origin. This is called the parent graph because this is the most simplified version there is of a parabola. So what we're going to do now is we're going to take the parent graph and we're going to graph it, and then we're going to start changing it. So first of all, the table, I think, started at -3 and went to +3. So I'm going to make this a -3. And then the next one was a -2. Oopsie. And then a -1. And then a 0. And then a 1. And a 2 and a 3. Okay. So -3 is at 9. So I'm going to fill that in on my table. -3 is at 9. And if you go back and look at the table again, -2 is at 4, -1 is at 1, and 0 is at 0. Okay, and now I just need to fill in 1, 2, and 3 on my table. So on our table, 1, 2, and 3 are at 1, 4, and 9. So what I'm going to do now is I'm going to plot these points. And when you connect the dots, okay, I did a really bad job connecting the dots, but it'll be okay. When you connect the dots, you get your parabola, the graph of the parent function. So what we're going to do now is we are going to graph each of these functions. If you look, the parent graph is right here, y equals x squared. Each of these 6 equations looks a little different than y equals x squared. I've either added something to the end of it, like this here, or I subtracted something from the end of it, like this here, or I subtracted something inside the parentheses, like C, or I added something in the parentheses like D. And we're going to see how that transforms or changes the graph. So when it says graph each function, all I'm going to do is just type it into the table and let you see it. You do not have to graph it at home. I just am doing it for visual purposes. So the parent graph is already, the parent graph has already been graphed. It's right here. So what I'm going to do is I am going to see if I can get another function here. Whoopsie. There's got to be another way to get a function, guys. Well, give me just a moment. I'm going to figure this out. Ha! There we go. We're going to do it. I don't know if there's another way I can get another color or not, guys. Just bear with me. There we go. There. All right, thank you for bearing with me. Okay, so the original function, the parent function, y equals x squared, is here. So now what we're going to do, I'm going to graph this equation right here. So x squared with a minus 7 on the end. So x squared and then minus 7 on the end. And when we do, we get this blue graph. So the original orange graph is here at 0, 0, where the vertex is. Now the vertex is all the way down here at 0, negative 7. So what's happened is that the graph shifted down 7 units. So by subtracting 7 on the end, it shifted the graph down. So under A, it says, describe how the parent graph was transformed. I'm going to say it shifted down 7 units. Okay? So if this shifted down 7 by subtracting 7, can you guess what's going to happen if we add 3 instead of subtracting 7? Okay, I bet you can guess. So let's go ahead and let's look at it. So I'm going to take this equation and I'm going to do plus 3 instead of minus 7. So again, the parent graph, the original one, is the orange one. And now when we put plus 3 on the end, the vertex was at 0, 0 and it jumped up all the way to 0, 3. So when you add something to the end, it actually shifts it up. So that kind of makes sense. If you subtract something from the end, it shifted it down. And if you add something to the end, like we did right here, it moves it up. So for B, how was it transformed? It was shifted up 3 units. So just to recap that, minus 7 on the end shifted it down 7, plus 3 on the end moved it up 3. So on C and D, what we're going to look at now is what happens if you add and subtract, not on the end like we did on A and B, but inside the parentheses. That's how C and D are different. So this one has a minus 4, but it's inside the parentheses. So let's change that graph and see what happens. So it was parentheses, x minus 4, close the parentheses, squared. So again, the original graph is the orange one, and now the new graph is the blue one. So it didn't move it didn't move up or down. So we know that. What it did is it took the vertex 0, 0 and it moved it here to 4, 0. So it shifted it to the right 4 units. Remember, orange is the old one, blue is the new one. So it shifted right 4 units. So by subtracting 4 inside the parentheses, it doesn't move it up or down, it moved it right 4 units. Okay? Now on D, I bet you can guess, but let's look at it. So now instead of adding on the end of the problem, we're going to add inside the parentheses. So like on B, we added on the end. On D, we're adding in the parentheses. So let's go and let's see what happens. So there we go. So if the other one moved it right, I bet you guessed this one would move it left. And it did. So the vertex at 0, 0 is now shifted over here to negative 6, 0. So when you add in the parentheses right here, it moves it left. So it went left 6 units. Now one thing I want to mention about this is on A and B, it made sense. If it was minus on the outside, it went down. If it was plus on the outside, it went up. But here, in the parentheses, it's kind of backwards to how we thought it would be. So the left and right movement is actually opposite. So we've seen that before when we graphed in vertex form. I always told you if it's in the parentheses, it's opposite of what you think. And it's the same thing here. When we see minus 4, our brains typically think it's going to go left 4. but it's opposite when it's inside the parentheses. It goes right 4. And same thing on D. When we see plus 6, our brain wants to think, oh, it's probably going to move it right 6. But again, it's opposite. So if it's plus 6 and it's inside the parentheses, it's going to trick you, and it's actually going to move it left 6. So that's kind of tricky right there. So now on E and F, I combined adding things inside the parentheses and adding things on the outside of the parentheses. So I combined them 2 steps in one. So on these, you're going to see 2 transformations happen. You're going to see it move left and right and up or down. Okay, so now let's graph these and see what happens. So I'm going to go back to our graph, and it was -3 inside the parentheses, and then it was +1 on the end. There we go. So the new graph is the blue graph. So it was at 0, 0. And now it got moved right and up. So 2 things happened. It got moved right 3, and it got moved up 1. So I'm going to say that this went right 3 units, and it went up 1 unit. And if you look, remember I said if it's in the parentheses, that's left or right. Since it's minus, it's going to be opposite of what we think. So -3 is going to move it right 3. And then the +1 on the end here moves it up and down, and that doesn't trick us. So +1 is going to go up 1. So if it's inside the parentheses, it moves it left and right. If it's outside of the parentheses, it moves it up and down. So with that being said, before I even graph this one, let's take a guess at what's going to happen, and then we'll go check the graph to make sure we're right. So I'm going to do it in the opposite order. So let's start with the number inside the parentheses. Remember, inside the parentheses moves it left or right. So, and it tricks you. So this +5 makes us think right 5, but really it's going to move it left 5. So I'm going to put L/R when it's right here in the parentheses because it's either left or right. And then the number on the end, I'm going to put U/D. That moves it up or down. And that one doesn't trick us. So -4 means it's going to move down 4. So my guess is from the parent graph, x squared, here's the parent graph, that this is going to move left 5 units and down 4 units. So now let's type it in and check our work. All right, so the original graph was at 0, 0, and now it got moved left 1, 2, 3, 4, 5, and down 1, 2, 3, 4. So, yep, it did, guys. It went left and down, and that's exactly what we said, left 5 and down 4. So, this right here just basically sums it up. It just talks about what happens in general. So, right here we have x minus h squared plus k. This might look a little similar to vertex form. Vertex form has an A in the front of it, but we'll get to that later this week. But first of all I want to do is talk about the h and the k. So it says h, this guy right here, is going to move the graph left, and that's if it's a plus sign, or right. And that's if it's a minus sign, because remember, h is inside the parentheses, and it's going to be opposite of what we think. So if it said something like +3, it would actually move it left 3. That's why I put the plus sign there. And if it said something like -3, that would mean it actually moves it right 3, so that's why I put the minus. Now k moves the graph up or down. And k doesn't trick us. So k is going to be plus for up and minus for down. So on the outside of the parentheses, it moves it up or down. On the inside of the parentheses, it moves it left or right. So now you have these 6 problems, and you do not have to graph these. All I want you to do is tell me how is this graph going to change from x squared? Do you think it moved up 1, down 1, left 7, 8, whatever, all right 9? That's what I want you to figure out. So that's all you have to write on A, B, C, D, E, and F on number 3. So once you do this section, you can either take a picture of it and upload it, or you can do it on notebook paper and upload it that way. But what I need to see from you is number 3, A through F, and that is what you're going to be turning in for a daily grade. Shouldn't take you very long at all. You just follow this pattern. Remember, if it's on the outside of the parentheses, it moves it up or down. If it's on the inside of the parentheses, it moves it left or right. All right, guys, have a great day. Bye.